There we go. All right, hey, it's MCU Monday. I have an MCU here. How convenient. It's extremely convenient because this thing we got for free at the Risk 5 Summit last week, as can you online. So, what is the Risk 5 Summit? What is Risk? It's an open source instruction set for microcontrollers and things. So, you can find our recap of the entire summit here on Hackster.io/videos. But also, yeah, this was like one of the last things that we saw as we were kind of like scooting out the door. But it turns out they just had like a huge box of these things that they were giving away. This thing, as described on the site abopen.com, which has a lot of good info on this, is being given away to help promote the open source instruction set, Risk/OpenISA. So that's pretty cool. If you go to open-isa.org, since this is what everyone's going to be most excited about, you just hit order board and you get it for free. Just put your info in here. And in some places, I think in the article here, it says that it's only available to people who live in the US. That is not so anymore. I went to their Twitter and it says that you can get it wherever. Just put your whole address in and they'll be able to find you. So that's super cool. So what is this thing? Let's take a look and get it out of the box. I love boxes. I especially love opening them. This one does not have any special defense features. So it comes with this little getting started guide. Let's focus on that a little bit better. So yeah, the VEGA code. It's got a little like, what kind of looks like a little smiley face, but I don't know what language that's supposed to be, but okay. Anyway, get started. Connect the VEGA board to a PC using the included micro USB cable. Oh, they gave us one. That's nice. Tilt the board in any direction, and the RGB LED should change colors to get software tools, blah, 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 blah. OpenISA.org. Design, create, and share. The brackets here are definitely necessary. I love it. So we have this pin diagram, extremely useful. Reset button, OpenSDA USB, we'll come back to that. The RV32M1 is the SoC here that's made by Freescale that it's kind of named after. And then you've got, yeah, these Arduino compatible headers so that you can plug in Arduino shields and use it with this directly, which is pretty cool. Bunch of other buttons. Who wants to look at a picture when we can look at the real thing? Let's have a look. I know y'all only tune in for my sound effects, so I'll try not to disappoint. Here we go. Sweet. So we've got a chip antenna here. Or not chip, what do you call it? The one that's printed on the board. PCB antenna thing. Embarrassing. And physical antenna connector here so that you can get really good range on your 802.15.4 networking. Here is that's a different one. It's also a Freescale chip, but it's something else. RV32M1 is here. And what was I going to say? Oh yeah, it's got a bunch of stuff built in. So as they mentioned, you're supposed to just give it power and then it does magic. So let's see, which, actually this is kind of useful. Okay, fine. Okay, it goes in there, good. The other one is basically, OpenSDA is basically debugging. So, ooh, look at that. We've got an accelerometer built in. There's also a magnetometer. Whoa. Amazing. What if I turn it upside down? What color do we get? Yellow again. Cool. So that must be the z-axis. The sky must be, you know, whichever x or y, and then red is the other x or y. I never know what to expect. If there's like a standard for which, like if the long way is x and the short way is y, or vice versa, you've got text going in there. Wait, sometimes they print a little thing on the PCB that tells you which thing is which axis. Here it does not appear they have done so unless they put a sticker over it. Although it also appears that they have little markings on the silk screen for where the labels go, so they probably don't have it underneath one of those. I don't know what that means. Does it mean that I don't touch it? I'm totally gonna touch it. I'm the worst person. Anyway, you could like pretty easily figure that out. Hit reset. Why not? There was a thing I was going to say that was actually useful. Let's just take a look at what it includes based on this article. You've got 4 megabytes of. Oh yeah, there's an micro SD card slot here, and I asked them whether this is for an RTC, like a real-time clock, so that it could, for example, lots of electronics that require a constant knowledge, like a consistent timing, like if you turn it off, then it still knows that it's like 5 hours since you first plugged it in or something like that. So for like constant timekeeping. However, that's not the case in this case. It is not for a clock. It is for the extremely low power Freescale chip. We'll come back to that as well. So it's based on this PULP platform, which stands for something ultra low power. Maybe it's a recursive acronym, like PULP ultra low power, and then the PULP stands for PULP ultra. Anyway, yeah, so we have this. Let's look at the list of options. Okay, so you've got the micro SD card holder, which I forgot to show you because I got excited about PULP. 4 megabytes of flash memory, a visible light sensor, a digital sensor with an accelerometer and a magnetometer, an OpenISA serial and debug adapter, that is the other micro USB slot on here. Speaking of which, there's a page for that on NXP's site. OpenSDA is a serial and debug adapter built into several NXP evaluation boards. That's all you really need to know about that. A user-accessible RGB LED and 4 push-button switches. Where are those? Oh, here we go. Okay. I see 2 of them. Oh, no. They're all on the right side. Along with a printed F antenna. That's what it's called. With an SMA connector for an optional external antenna. Connectivity to external hardware is provided via Arduino-compatible input/output headers. Yeah, so here are your 4 buttons along here. Nothing is currently programmed in to happen with those. Here's your Arduino thingies. Here's your printed F antenna and the other connector. And then there's the debug port. Cool. And here's the micro SD card slot so that you can expand it with extra stuff. I was kind of wondering if it was like a SIM card or something, but it's obviously not the same connector anyway. So I have some more little pages for you to look at here. Here's the OpenISA site again, open-isa.org. They have a whole getting started section. This whole site is really nicely set up, by the way. There's this tab up here that says get started. There's developers, download, order. And step 2 is download your software. Your board is ready and ready to go. They've got SDKs for Windows, Linux, and Mac. Glorious! Serial port driver for Windows only. I'm assuming that the other systems don't require a driver. That's often the case. Sorry, Windows people. You made your choices. An IDE for... an Eclipse IDE for C and C++ developers. I kind of wonder if that has to do with the Arduino stuff. Yeah, like, does it run Arduino stuff natively? I'm not sure. I could look that up. I have not yet. You can look it up. All this stuff is open source. You can check it out on GitHub, OpenISA.org. Then the PULP platform that I mentioned earlier, the ultra-low power, also has its site at pulp-platform.org. That's linked in the description to this video. You can get the source code for that stuff on GitHub as well, pulp-platform/RISC-V if you want. I love that all their cores and stuff are named in these cute little punny names. Like this one is Risky, only with like a 5 instead. And then they've got, that's like based on another one that's called Orion, only it's like OR10N, a CPU core. So good! And PULP features efficient implementations of RISC-V cores. These include the Risky, the Zero Risky, and Micro Risky, and then this other one. You can read all this stuff. Another thing that was interesting to me is a term that I've never heard of before. I love hearing of new units. So in this case, I learned about the unit PJ/OP, which stands for petajoules per operation. And that's equivalent to gigaops per milliwatt. So you can measure it either in petajoules for a single operation, or how many billion operations you can do for a milliwatt of energy. Anything that's operating on that power level is kind of ridiculous, and so it kind of blows my mind that people are actually needing to use these units, but I think it's really cool. Another rabbit hole for another day. Oh my. So anyway, yeah, check out the article if you want to learn just sort of the basics. We kind of covered it already. Go to open-isa.org for the sort of high-level stuff. Check out their GitHub and the Pulp platform GitHub if you want to really dive in. And of course, order your own. Just hit the just hit the button at the top, order board, or the tab at the top right, and you'll be able to get your own one now for free. Just put your entire address in, like, maybe this excited to build area or whatever, and you'll be able to get your board and play, design, build the next big thing. But they're kind of little things, right? Because they're like super low power and like, anyway. Yeah, thanks for watching. Have an awesome rest of your MCU Monday. Go get your some free stuff.